Yeah, thanks everybody for joining. Kubeflow is like a really broad world. There's a lot of applications that you can apply it to, and so Ryan and I were talking this week about how there's if you look at the resources and you start to study, you find that there's some really simple resources that go over high level stuff and give you just very basic examples, and then there's very specific resources that go into specific examples. A lot of times they're a bit complex, and then also a lot of times they hide a lot of the details. So they just say, here's an image. So you pull this image, and then everything runs. You don't really get to see the internals of that image. And so yeah, what we've got here is sort of trying to bridge that gap. There's still a lot more out there than what we can cover today, but I think Ryan has done an awesome job of putting these slides together and explaining some of the components and what goes into them. And so, yeah, we've got that. We've got a few links that you guys can look at the end as well. And so, yeah, with that, I think I'll pass it to you, Ryan. Okay. Take it away.
All right, thanks. I mean, so Daniel definitely will step in here. I still think there's a lot to know. The like he said, the breadth and the depth of this this application, if you will, is extreme. It's big. So, but the good thing is I think we've got a good starting point for the team. We've got a pipeline, and I definitely think the devil's in the details in terms of to really understand it, get it. You've got to go through and kind of build one of these things yourself to kind of understand where the gotchas are and where they're not. So hopefully we can kind of communicate that well with everyone today. So what I've done, and this was kind of a challenge from Brian this week to try to become as versed as I could in Kubeflow. I had a little bit of experience with it. Didn't spend a ton of time with it, but it was where we were definitely going to head. But I definitely spent a lot of time this week, trying to read the docs and understand the deep side of it. I'm not a Kubernetes expert by any mean, but just to kind of make it at a high level, and I'll get into some code too. So, Kubeflow is a way to run machine learning pipelines on Kubernetes. And so all the concepts for Kubernetes apply to this. And one of the things to remember here, recall, is that Kubernetes, right? Every single one of these steps in a pipeline is a component, is the kind of the terminology that's used. And they represent individual pods on a Kubernetes, deployment. So these are pods that are inside there that that you interconnect via essentially a command line interface, which we'll go into that kind of how those work. But so the goal of this for me, kind of how I took this on this week, was to kind of have twofold problems, right? I wanted to understand Kubeflow and how to build my own pipeline, but also two, we wanted to apply it to like an IoT style problem. So that's what I attempted to do here. So again, this presentation should hopefully provide like just I'll call it a gentle introduction to Kubeflow pipelines and how to build and pass data between components. And also too, if interested, we'll kind of go deeper and talk a little bit about the unsupervised model, right? Using an autocoder for anomaly detection. In fact, this is the exact approach that Bobby, I think, is taking. We spoke yesterday about what he's doing, and this is the approach I think they're headed with. So the data set I used for this was this NASA acoustics and vibration data set. So this is interesting. So the data set itself got vibration data from 4 bearings in it, and it's broken up into these 10-minute snapshots, and each 10-minute snapshot's a 1-minute interval of sampling at 20 kilohertz. All right, so there's 4 bearings each one of these. So this data is now located up in our amazing data sets for the public sets. That's kind of where that's where this top pipeline will kind of pull from. So kind of talk about what each one of these things does. So and then we'll dive into the details. So this load raw data step here, the goal here is to go and reach out to that individual bucket, that amazing public data bucket, and create an aggregate by taking the mean absolute value of each bearing file. So essentially, because right, there are these snapshots of 1 minute for each 10, and they're 10 minutes separated. Sorry, and so we're just taking an aggregation of that file, and that represents one point in time. Then this I have this run data describe thing because I wanted to have this experience doing this. This will generate plots and some CSV outputs of a few different TSA type metrics, and it outputs those to, again, a local GCS bucket under data describe. So it throws the data there. Because this was a unsupervised learning problem, this was kind of used more like to say, hey, you can look at this. This is kind of some things you can see, features see about the data. We're not necessarily using the features to go in and train the data. But I went ahead and just said, let's just train it for what we got. But I think there's definitely there may be some value here in doing that. So splitting the data. So this component takes the aggregated raw data as the input and normalizes it if you've specified it, and it will split it out into, we'll call them a test and a training set. So the training set really is just, since it's an unsupervised problem, it represents a good point in time of the data. So the bearings were working well and there was no failure. So that's the training set. Because ultimately what you're trying to do with an autoencoder in an unsupervised way is you're trying to teach the data, what does good look like? And then once bad comes along, it looks different. It's outside of that distribution. So it's really easy. It should be easy to detect. So the test set is when the bearing started to fail. And so that's the difference there. So there was just, the data set was just split by time. And that's what this component does here. And then this component here submits the training job to AI platform to train. So it takes that TensorFlow model in there and submits it to AI platform to train that. And I was trying something funky here. They're benign for now though. But anyway, any questions about the over in the pipeline or any of the components? Okay. All right, so we'll kind of go through this in the Jupyter notebook. So there's three main parts. So we're going to start at high level and keep getting deeper into the weeds here. So the sensor training pipeline.py is kind of the main file that ultimately describes the Kubeflow deployment, the YAML file that's going to go out and tell Kubeflow how to run this thing. So let's go over to the notebook here and look at that file here. So it's kind of separated into three parts here. One of the ways recommended to bring, when you're building up this file, to bring inputs into this that are outside of the pipeline itself, is just setting environment variables. That's one way to do it. So ultimately, this thing goes and gets a bunch of environment variables when it's being compiled. And then next thing, let me make this a little bit bigger, make it a little bit easier to read. And then this part of the section of the code here is going to create the components for each part of the pipeline, right? So when you're talking about these Kubeflow pipelines, you're talking about components, and the components make up those pipelines. So we'll talk about each one of those specifically after, and then this simple pipeline here we put together. And so essentially decorate it, and then you create your pipeline function and connect all these pieces together. All right, so that's kind of the overall view of that. Any questions? This is the highlight. We'll get into the details, but are there questions at this point? Okay. This is definitely a discussion. I don't want this to just be a presentation, but this helps me organize my thoughts.
So just a real quick question. When you develop this, then you don't start a notebook, but you start kind of with a Py file and then a line, or how do you go about, like?
That's awesome question. I actually did start the notebook, and I had it just write the file out to a Python, a flat file here. So yeah, definitely. I thought the notebook was a good way to kind of iteratively through this. So I'll actually go through this notebook too when we get there. But the file itself that's created for this pipeline is this first cell in the notebook, and it just writes it out to that location. And I would definitely recommend a notebook is a really good way to really organize your thoughts through these, because you're gonna have to build some Docker images as well. And so I think it's nice to just kind of put it all in one place and then just ship the files out. So a good question. All right. So components. So let's talk about components. All right. So there's and Daniel can step in here too. Definitely, I think he understands a little bit deeper the underlying pinnings here. But there's three main ways to build Kubeflow components, and the basic way that is expected that you do is a user just brings their own custom container or Docker image to the rodeo. So that's kind of the first way to do this. So in this case, for the data describe part of this pipeline, I did that. I created a Docker image that had data describe built into it, and it runs through that EDA and dumps all those files out in GCS. And so that's just, I bring that in. It's a custom way to do it. And so the way you define those is you kind of define your function here. And what you on the inputs here, you're just putting the inputs that the pipeline is you're going to pass in when you get to the pipeline, and then what you return is this domain-specific language container object, and you give it a name. You give it the image that you've built that you want to go and grab out of GCR. So that's another thing, right? The image needs to go be in the container registry. And then you provide the arguments. You'll notice the arguments here are just what's being passed into this function, because this is going to go into the pipeline. So you'll have, in this case, it's really simple. I just give it a route, essentially where to go get the data from and where that data lives, and then it'll spit it out in a prescribed location. So this is a really simple way to do this. Yeah, go ahead, Daniel.
I'll add that there are more command line arguments to this, and so this is like kind of the heavyweight container op, because that image by itself can have commands that run. You can run scripts inside of it, yeah, basically anything you can do in a container. And then there's also a few other options to this. So there's there's a lot you can do with the container op. But it is kind of black box as well, because whatever's going on in that image, of course, you've already built that in Docker or pulled it from somewhere.
Yeah, that's a good point. And there is a lot. This is probably the minimum amount you need to make this thing work. There's a lot that you can actually add into this. And Dan, did you have I think we have the docs linked at the end here. I think maybe for this guy especially. So this is
yeah. There. I'm not sure if I do for this one. If I don't, I'll add it.
Right. And I'll bring it up right now. They're obviously, I'm doing a lot of stuff. I'm sending a lot of data out to Google Cloud. And the reason I did that so that I had visibility into what's happening with the pipeline while I was building this. I don't think that's the best way per se to do things, because that's a lot of IO outside of the cluster. And so when you get to like intermediate component steps, one of the better ways to pass data, and I'm still kind of exploring this, I think Daniel has a better idea of it, is essentially writing files to the persistent volume on the cluster, right? Just passing it in between the cache the cluster's already got set up. You can drop it there, and the next component knows where to pick it up. So that's one thing. And then AI platform training, it does things a little bit differently too, but it also does write files locally to the cluster, or actually in Google Storage. But all right.
Yeah,
cool.
We do have a link to that. I'm certain of that. So there's a link at the end of this presentation on that's data passing. So you can pass data between components, and it kind of depends on the size of the data. If it's small, you can just pass it with arguments. If it's larger, then you need to use paths. But you've got to think each component is a separate container, so you can't just tell it, well, here's my file. That container has to know where it is, and so there's a way of passing data. And that link goes over it in more detail. So I'll point you to that.
Yeah, I think the next component, when we talk, it will explain a little bit better too, because it makes a little bit more sense. So sorry, I just exited that. Let's go to the next one. So the next way to kind of create a component in Kubeflow is to actually build just a Python function, and then let Kubeflow take that function and stuff it into either its own container that it builds, or a custom container that you defined, right? So this is, again, a scenario where you say, okay, here's an image of the environment that I like, and I want you to run in, so use this image, which is what I did here. Or the other one is, okay, here's a list of packages, install these, and build this image for me. So there's two ways to do that. So so for this case, this is in the pipeline. This is the components these two components here, the load raw data and the split data. These are actually functions that have been converted to container ops. And I'll show you exactly what those are. But in the files here, and I'm going to get this up to our Bitbucket so that we all have it. But this is where it's located here. Let me go to that. So I have a file in here that's part of the pipelines folder. It's called Func Components. It's the functional components, the components that I wanted Kubeflow to build from Python functions. So kind of the structure of a file like this is your only thing you need to import is this named tuple. And I'll talk about why that is. But everything else, when you're defining these functions, you import them within the function itself. And that is because Kubeflow is going to take that information, and that's what it's going to know how to run your function when it takes it and deploys it to the container of your choice, or to the container it builds. So in this case, this is this load raw data function. And when you're using the Kubeflow DSL, it's really important that you have to define your inputs and what types they are. so it knows what to expect, right? So you tell it, like in this case, I'm just passing a bunch of, like I'm passing a source bucket name, a prefix, and then a destination bucket and a destination file. These are all strings. And then essentially you say, okay, these are all my inputs. And so you actually upfront define your outputs as well. So use a little arrow here. And if you have more than one output, that's where that named tuples object comes into play. If you're just going to say, just spit out one kind of object or one thing, then you can go ahead and just say, you know, output string or output Boolean, right? You can just give it what you have. But in this case, I've got more than one output. So I use this name tuple. There's a name here. It's completely a dummy name. You can call it whatever you want. Outputs is kind of the standard, but it doesn't have to be. It can be whatever you want it to be. And then you actually list your outputs. Now this matters. The naming convention matters because this is what this will be called when the next component tries to access it, right? So downstream. So downstream components, when they're trying, you'll see this when I kind of tie this together, that they have to be called the same thing. And you can also again tell it what type of data that it's passing. So in this case, I'm just passing pretty much destinations, right? I'm not passing all the data. I'm just passing destinations where I put data and where I've gotten data. Does that make sense? Okay, so other than that, that's pretty much it. Then after that, you just go ahead and write your function like you normally would. So this function again is just, it's taking in, is reading from the public bucket, going through and just aggregating up the data and dumping it to a local bucket for the project to access. So this is the most critical part of this. And then after that, you just define it. And then of course, when you return it, you just need to return back the objects, the outputs you said you were going to. And in the same name. And then so here's another function, same thing. So I got these 4 inputs. One of them is a Boolean, and then outputting these a bucket name and some destinations, some files. So yeah, then after that, you just write your function as you normally would. So, any questions about functions? And then so in the pipeline, what that looks like is I import those in, right? So from my functional components file, I import both of those functions in, and I load them up into these retrieve raw data op and split preprocessed data op. And that uses this function to container op function. And I sell it, all right, this is the function you're going to use. And in my case, I said, you're going to go build it with this base image that I've already built. And same thing with split preprocessed data op. Here's the function. You're going to grab that split data function, and you're using my base image that I built. And so this is in the components definition part of the script. Does that make sense? And if you just want to use like, if you don't want to use your custom container, you just want to use vanilla Python because you do something really simple, you're just, I don't know, iterating through something and describing some simple things, you can use the standard library for it. Then you just don't define a base image. You just go ahead and pass it like this, and it'll just take that function and it'll put it in essentially just a vanilla container and run it. So any questions on a function to container ops?
So when you talk about when you don't send a base image, what is it? What is the base image then? Who defines what that looks like? The default.
Yeah.
How do I know what's installed on it? Basically,
that's a good question. I haven't found the answer to what's exactly installed, but the assumption. Daniel's got it.
Yeah. So there's actually a default base image, and it may depend on the KFP version, but at least the latest version, it's a TensorFlow image. So it's like TensorFlow 1.14. It's a Docker image based on TensorFlow. So it will use that image if you don't specify a base image.
Cool.
And that's got Linux underneath it. So you've got access to Linux functionality, but it is fairly basic as well. So if you're thinking about using like anything special, you probably want to make sure you get an image that includes that.
So yeah, you probably only get TensorFlow. You won't get pandas. You won't get anything else. You're going to get TensorFlow and then the standard library, I think, right?
I'm not sure on that, but that is, yeah. So that's something you can look up on Docker Hub. You can look up that TensorFlow base image, so that func to container op, the function signature should have that exact image name that it uses as the default. So you can look at that and then look up that image on Docker Hub.
Yeah. Let's see here.
Oh yeah, this is real time. Here we go.
There you go. Yeah, it's a TensorFlow 1.13, Python 3.
Yeah, so that's the default image.
Okay. Good question.
Oh, thank you.
All right. Okay. So that's the Python function to container ops. That's the second way you can do this. And then the last way is Kubeflow comes prepackaged, or they've got in their GitHub repo several different prepackaged components for lots of different platforms. They got for AWS, for GCP, and everything else like that too. So specifically, the ones of note I thought were interesting on GCP, and one I actually used in this was the ML Engine train component, the ML Engine deploy. So you can actually, of course, they're calling it ML Engine because that's what AI platform was once upon a time. BigQuery query, so you can query BigQuery and then submit a PySpark job if you've got if Dataproc's up and going, you got a cluster going there. So I thought those are interesting. So we specifically use the ML Engine train. That's how I'm submitting my train job. So in the components code, this is kind of how you end up. You just have the component store, you load the component, you tell it which component. There is a place where I define where to get these. I'll show you in the notebook, and then that creates the op component. And then we'll talk about this later, but this is how you kind of define it in the pipeline itself. So once you've got it, it's here. These are some arguments that go into it, and you build that up. So let's actually, this is worth and so what specifically, again, when you're submitting this job, the way I went about this is used a custom image that I built that I loaded into GCR. So it had the TensorFlow version I wanted, everything, put it up into there. So I provided in there the training script that was needed in the image. I supplied the input args required to run the job. So these are got to be command line. I'll show a fun little trick on how to do that. And then the location of that image in GCR if you've got a custom image. So this is kind of what you would need to do with a custom image. You guys are probably more versed in using AI platform for training things. So there's different ways to do this for sure. In fact, this component, if you go to GitHub and look at the inputs, there's quite a bit of flexibility you have here. And this is just the route I went because I could understand it. And by default, this thing doesn't output. What it outputs is a job ID, which is the job ID on a platform that runs, and also the job directory where it runs. So like the job directory is a GCS path that contains anything you've written out during the training. So let's go look at that because I think there's quite a bit there to understand. Right, so I started out with just creating this training script here. In the training script, I defined this as a function to be ran, and then the inputs for it are just going to bucket. Where's the training file? Where's the test file? What is this job directory? How long do you want to train this by? What batch size do we want to use for TensorFlow? Obviously, you can specify all your different parameter tunings in here. This is also where you would specify any kind of hyperparameter tuning that you would do. I didn't do anything for that like that for this. I was just trying to get the pipeline up and going. But there's a lot of options, and there also is an example of how to use the hyperparameter tuning inside of this type of image here. But simple autoencoder model using LSTM, since it's a time series based model. I don't go into the details of that today, but just find a simple model here, compile it, and then just go ahead and run it and track the history. And then I just began to create this little save to GCS function where I just kind of save everything out so I could look at it in Google Cloud Storage. Sent out a CSV file of the loss and validation loss, created metrics for it, created the images for that, different types of things and artifacts that I put in GCS. I'll pull those up. But yeah, that's kind of the idea here. There's nothing really that it outputs. It just does all the work. And then this is really fun. I don't know if anyone's familiar with the Fire library. This is something I learned just recently. But if I don't know, I remember my time when I was making these types of scripts where you'd actually use argparse or argv or whatever to list out all your command line arguments that you got to grab if this thing's ran as a command line argument. Well, if you use Fire, the library Fire, is pretty cool. It looks at your inputs for your function and will set up optional and required inputs based on the names of these things, and then just put that out. So that makes, I don't know, makes it really nice. And you have to define, instead of having to define all these arguments on the flip side here, it just grabs them up for you real quick and combines that for you.
It works the same way as args parse, so you just have to pass command line options to the command.
Exactly. Yep. So your args will just be called the names of these inputs. So that's what you have to keep track of. But yeah, it makes it really slick.
Ryan, can I ask you another question?
Yeah.
It looks like this file can run independent of Kubeflow. Like I could just run this file. Is that all I need to do to get Kubeflow pipelines working? Is get something like this going? Like this looks easy, and then connecting it to Kubeflow pipelines is nothing. It looks like. Is that?
That's fairly true. Yeah, the hard part is really just kind of getting the infrastructure put together. I mean, that's one of the programming principles that Kubeflow brings up when you're building components, is that your components should run standalone. They have to be able to. So like if you, whether it's in the container or on a code, they have to be able to run standalone. So that's like, makes sense. But yeah, that's really kind of how you do all these. If you can run standalone, then ideally it can be packaged up.
And so if I did a sample run on this train.py file, and then I put it on Kubeflow and just sent a massive amount of data, it should all just scale and run on its own. I don't have to worry about it. Okay, that's awesome.
Yep. Yeah, we'll run. See that we're doing on time. We're doing well. We'll run my pipeline at the end here and kind of walk and see how that goes. It doesn't take too long either. This is a really small STM model. It just trains about 6 minutes. It's pretty fast. And actually 5 of those minutes is just Kubeflow spinning up. So it's pretty fast. Okay, so let's kind of, I think for just kind of interest, I'm going to kind of explain the problem a little bit. I'll go into, let me duplicate this real quick. Let me show you the artifacts a little bit, because I think there's definitely, we're talking a lot about anomaly detection right now. I think that's kind of a hot topic. So I'll show some of the information there that's being spit out by this thing. Help understand the problem a little bit. So it's the most recent run here. So in this case, right, we've got this metric CSV, which is the loss versus validation loss, which will show, oh, dang, I didn't hit back. My bad. But like, kind of how you're doing this, right? So this is the training results, right? So you can see just kind of by it's kind of hard to see. Let me zoom in a bit. Right, based on the train and the loss data, there's kind of this sharp learn where this thing starts picking up. But definitely these things eventually converge, which is usually what you want to see with an unsupervised learning method, especially with like an autoencoder. Now, what you're doing again is how you're like detecting whether or not something is an anomaly is, right. This is the loss distribution for what all is the good data, right? So this represents what's good, and this is the loss mean absolute error. And ideally, what you would see is if if something is outside of the norm, when you go and predict on it and then compare it back to what the original input was, the error is going to be much larger than what you would expect to see in this distribution. So ultimately, what my script is doing is just picking the highest point in this distribution. I went ahead and add a 5% buffer to it, just to because trying to prevent some chatter potentially if we're trying to detect issues with a sensor, and then that value now becomes the threshold. So what you're looking at then is something like this, where this is normal behavior. So this is the mean absolute error over time, right? So this is normal behavior for all 4 of these bearings that are inside this file. And then this is the threshold that was picked. And then eventually you can start to see where this bearing eventually runs to failure. So this is the failure point here. So, it's pretty good at predicting about when, what, you're past this point now, you're up in this land, you probably should look at, replacing your bearing. Obviously, there's probably a cost optimization has to be kind of looked at here, where you still have a lot of life potentially in this bearing, but it kind of depends then from what the product is or what you're doing that way. But anyway, I hope that explains the problem a little bit too. So for those who are curious, but that's what this is doing. So any questions about that?
Can you explain? So right here, what is the x-axis here? Is that time?
It is, yeah. I removed the time index from the data at this point, so this is just the index in the pandas data framework. That's just the index number for the value. But yeah, this is over time, so this is time ordered. So this is like first of life. This is end of life here, and these are the time increments in between. This would be, each point would be 10 minutes. Yeah.
So how did you know that that was the time frame you should look at? How do you know that the failure should be within this 1,000? I don't know if this is milliseconds or minutes or whatever.
Yeah. And how do I know this was like a good,
how do you know it's a good sample size to
right?
actually?
Yeah, that's kind of that's the hard part. So when you're definitely doing anomaly detection in general, you hope that you at least have at least one or two examples of what bad looks like or what bad is. And so so the idea is take everything that you know is good, model that, get that, understand what that distribution looks like. And then you take your test data set, which now could have good data in it, but also should have the bad data. And so in this case, based on the data set, this was the bad point. This was known right beforehand, but you just have that, you just know that, okay, so from this point on, this is when the bearing started to fail. And so that was known afterwards. So this case, these bearings were just run till they died. But in a case of a real life example, you would at least have one or two examples of what bad looks like, and that would become part of what your test set is. Does that answer your question? Cool. All right.
Yes, it does.
Cool. All righty. So, so submit the train job was really easy. Kind of going back to Bobby's question, you just kind of create that script and go for it and submit it up. So, we'll get into the pipeline here in a moment. Actually, we'll do it right now. So now the pipeline. So the idea, so these are all the components. You've built all the components. You have your pipeline built. You have all these components. Now it's how do you hook them all up? So that's where the pipeline part comes into play. So in this case, right, so when you define your pipeline, you just use the pipeline decorator to ultimately decorate your function. You give it a name, you give it some description that's ultimately going to be uploaded to Kubeflow, and then you define your pipeline run. And I need all the inputs that's required. So these are the inputs that will be reflected in Kubeflow as well. So I'll show you, you'll see what that means, but these are reflected in there. These are the required inputs to run your pipeline. And then you define all your components. And the big key here is, right, just kind of like Airflow or any other these DAG or these graph type systems, you're creating the architectures based on how you connect the outputs from one point to the inputs of another. So very simply here, I have this raw data component that runs, and this is the inputs for that. Well, I take raw data, and it now goes into this data describe output. You just take raw data dot outputs, and then again, going back to what the output was called in the input file, you just map that, and it's mapped. It's keep track of what that is, and that now becomes the input to this component, and that ultimately is what defines what this line here. It says, okay, this comes here, and there's like a dependency for this component on that component, so they must run in this order. You can also create dependencies just by mapping an input to a function and never using it, but you can just map it to it, and it can just literally be a dummy place file. That's kind of what these are doing, and that just creates a dependency. Or if you wanted to make sure that there's no race conditions, you don't want things to run at the same time, you want to make sure there's a sequence, you can use that as well. So one of the examples I saw online, it was doing a big query. There's 3 queries that are run simultaneously, but they were colliding with each other on a race condition. So there definitely is some help in creating some dependency. Even though there might not be real dependency, there might be a need to just create some dependency in terms of just processing sequence. All right, so actually, let's just go back to the notebook at this point. So, so here, here's my pipeline defined, and I've got all my components here. So I have the raw data one that's going to grab the data out of the public bucket and process it and create it into the data we're going to use. We have the output bucket for data describe. So that's that path that goes over here and dumps all that other information in another bucket. And then I have the split data, right? And it's dependent on the outputs of raw data. So you can see the split here. So raw data is here. There's a split here on raw data. There's a split here on raw data. And I'm taking those outputs and going on with that. In this case, right, I knew what the time was, where to split the data between, so I just hard coded it here. Not best practice by any means, but then training arc. So now that once split data gets done, it depends on the outputs of split data. So once it's done, then I can begin to set up what my training arguments are. I set up a job directory. You can use this nice little Kubeflow Pipelines run ID placeholder for your AI platform jobs, and then just plug that into the original component you made. You create an output for it, and you put in your inputs that were required, right? In this case, I had a trainer image that I built that it goes and gets. Anomaly detection was the prefix it's called, and there's that. So once you submit those, right, you go to jobs here, you'll see over the last few days, you can see these custom jobs have been running. So it submits those jobs. You can go look at the stack driver logs as well, and see what's going on there. So that's the pipeline file. And now, again, we kind of want to talk about how you set the environment, and I'll just go to the code for this part. So what I did here, there's a couple ways that you can actually set up and submit your job to Kubeflow. You can submit it through the Python, SDK. You can do it actually once you create that YAML file, which is ultimately what we're going to do here. You can upload it manually to Kubeflow, or you can go ahead and just use the command line interface, which is what I did. I just used the CLI to do it because I wanted to try it out. So in this case, right, this endpoint here. So I don't know if, I think Daniel mentioned this. We didn't go over this yet. To spin up a new instance, right? So if you look at pipelines here, right, you'll see I've got my pipeline test app here. And if you look at the GKE, you'd see in the compute engine there that there's a cluster spun up. But to do this, you need to make sure that you have some instance running where you're going to be deploying that to. And that's ultimately when you click on this, pipelines dashboard, this is what comes up is this page here. And there's a couple ways you can get the endpoint. This is the endpoint here. You just copy it out of the URL, or you can come over here to AI platform, hit settings here, and it kind of shows you how to use the Python interface to send stuff to your job, but also, the endpoint's right here as well. And this is how you can get all the pipelines that are listed in Kubeflow, or you can do it with the command line. Excuse me. So in this case, I set up, here's my region. These are all going to be environment variables here in a second. This is where I created my images. So I just, named them, versioned them, tell them where I'm going to send them, and then run G-Cloud build on those. I comment them out because you don't want to try to create them again if you already created them. So I've got these 3 images that I've created here, and the Docker files for each are located like in base image, data describe image or train image. So just really simple Docker files. I built a base image, and then I just based my other ones off of my base image and built them there. And you can see they're very, very straightforward Docker configurations. And then just compiling the pipeline. So this is something a little bit beyond me. I don't know if Daniel understands it better. This is using the Kubeflow pipeline service account. So this is by default. We just set up false. We'll just use our own service account to submit these. But I think you could use the Kubeflow service account for certain scenarios, and I'm not really sure what those scenarios might be, but just want to call that out. Daniel, do you have anything on that?
Yeah, I can take that. So basically, when you set up your Kubeflow cluster, and it may be at the Kubernetes level. I'm not sure if it's at the Kubeflow level or the Kubernetes level, but when you set things up, you can specify whether to use a service account or whether to just allow the API to be open. There's just a checkbox you can click there. If you check to allow it to be open, it's really easy. You can set things up really quickly, but it's not quite as secure. And so if you got like security requirements that require you to use a service account and keep everything under an IAM policy, then you want to click that box, or I think you want to leave it unclicked, and then you'll have to set up a service account that can interact with your Kubernetes environment.
It's a good call out. In fact, I'll show you where that is now that you bring that up. So when you go to create a new instance, if you wanted to create your own, a new cluster and deploy your pipeline to that cluster, you can obviously use what's available. So you just click on the, new instance. You configure it here in the marketplace, and you can select a cluster where you send it to. And then I think this is no, let's see. It's
so if you do
I think if you create a new cluster, here it is. Yeah. Yeah. So you can either allow access to from the APIs, which is what I did to make it easy, or you can leave that unchecked, and then you're gonna have to use a service account to actually be able to access the APIs that service account's allowed to access. Is that right, Daniel?
Yeah, that's right.
Okay. Yeah. So if you're gonna, so if you want to create your own cluster, you can do this, or you can select an existing one. We've got a couple of them up spinning. We probably need to spin them down here in a bit, but you create those clusters, and then you ultimately create an app instance that you're going to deploy to that cluster, which is what we're looking at here, right? So makes it really, really slick.
For example, you would not check that box and create the service account for security reasons.
I think so. Yeah, I think for these one-click kind of demo type things, it works well. Yep. But yeah, I think there's going to be that extra. You want to add that extra layer of security for more production deployments.
And a couple notes here. You can see it. There's a box for use managed storage. So you don't have to click that one either. If you do, then you need to supply a cloud bucket and an SQL instance, and it's going to keep track of your artifacts in those locations that you specify. I think the reason for that is like you could persist those pieces across clusters. So if you blow away your cluster, then you can go back to what you created. So there's definitely that. If you don't use managed storage, then your metadata is just stored on your cluster, as far as I understand it. Yeah, and I had one other point, but I don't remember it. So let's just keep going.
Awesome. So yeah, this is the link I'm using to go and get the custom components, the pre-built components out of Kubeflow's GitHub. So this is the link I've got here, and then just runtime version, Python version. Set those all up as environment variables, and then use the command line here. You can again use the Python SDK or whatever. DSL compile, you're compiling it from Python, the directory there, the location of that Python file, and then where you're going to actually put it out to, the output YAML for the deployment. So once that's compiled, you can then again use the Python SDK to submit this pipeline to Kubeflow. You can just manually take that YAML file, which is right here. You can manually take that file, go to Kubeflow here, go to pipelines, and upload the pipeline here. You just give it the location of where you're going to put that YAML file. Or you can just submit it right here through the command line, where you just provide the endpoint that you're doing a pipeline upload, whatever you want to name that pipeline, and then deployment file that you're going to upload there. And once it does that, if it successfully does that, it will return to you the details for that pipeline and your inputs that are required for that pipeline, and if there's a default value already defined for those. If the pipeline, one thing is the pipeline name exists, it will not overwrite it. It'll just error out and say, it'll give you a 500 error request 500 saying can't do that. So that's one thing, is the pipeline names need to be unique each time you do it. Now, kind of, I think, and this is just kind of what I've seen, pipelines represent kind of instances of maybe of a configuration, right? So you kind of want to use pipelines names to version kind of maybe a specific flow you were trying out or a specific thing. Experiments can be grouped together in experiments, and these different runs are actually, they tell you which pipeline they ran on, but experiments are something different, right? You kind of use experiments to group together. Okay, maybe they're the same pipeline, maybe they're different, but they're using them to group together the outputs or the results of what you're doing with that experiment. So kind of the way I've been thinking about it is pipeline versions. Pipelines are used to kind of tell you this is the configuration of the data that was used. And then, the experiment was, what was the output based on the inputs to the pipeline of that time. That's kind of, I think, the way to kind of separate those kind of create that mental model there. Yeah, so let's go ahead and run this thing. So once it's submitted, right, we've got it up here, and we can run it. So to run it, you just you can find the pipeline. You can create persistent runs that run on some kind of schedule, or you can just create a single run, which we'll do here. Just want to give it a name. So I've just been doing really basic names here. Any kind of description if you want to do it. You attach it to the run to an experiment. I haven't created a new experiment, so I've just been attaching it to the default experiment. This is the service account. Again, if you're going to use that service account, this is where you could define it here. You can, again, recurring or one-off. You can tell what you're going to do. We're just doing a one-off one. In this case, my pipeline requires these inputs. Now, again, these were defined by me. So project ID is required always. I give it the region as well because that's what AI platform needs to know. Where I'm getting my data from. So the bare raw data is in the amazing public data, and it's under this prefix here. And then where I'm going to put it is in this Rust and Kubeflow test. And let's go ahead and do this. Now, what's really cool about Kubeflow is if it looks at its cache when it goes to run, and if any of the variables are the same between runs, it will just skip that run because it's like, okay, nothing's changed here, which is what we're going to see here. I don't need to change anything. So if I hit start now, so I hit my run 11 here, I can click on it and we can watch its progress. So you can see here that there's these little, like, you know, it already saw, because back in run 10, these actually already ran and they created the data, and it's noticed that the data based on the inputs has not changed at all for these runs. So these just skip. So okay, these are already good. And now right now it's working on submitting the cloud job here, the AI cloud job. So if we wanted to check that out, we could go over to, you know, AI platform pipelines, look at jobs. And what we'd see here, right, is here's our training job. It's now running, and we can go to stack driver and check out where we're at. It's spinning up the job. So this is obviously the AI platform logs. This is what you'd see from the Python scripts point of view. From the Kubeflow point of view, you go also to the cluster logs and see again like where it's going, what it's doing here. So there's just a couple ways to troubleshoot this. This is obviously how the job's running on the cluster. The first time I did this, it was failing, and I learned that's because I actually had one of my inputs as an int, and it wasn't a string, so it was failing, but it was failing on the Kubeflow side and not on the AI platform side. So this was really helpful to kind of understand that. I'm still trying to understand this visualizations. This doesn't I'm not seeing this as much in the documents. I think this is going to be deprecated actually, from what I could see. And instead they're using artifacts, but artifacts isn't showing up as an option.
So wouldn't that be where you show your confusion matrix or your ROC curve in some Kubeflows?
Yes, yeah. So there are some pre-canned metadata that you can provide as artifacts, and if they meet a certain, that's kind of what I was testing with. Go back to the pipelines here. That's what I was testing and trying to understand with these right here. Just trying to create those. But yeah, you can create and say, okay, this is a confusion matrix type, and here's the data for it, and it will create a visualization for you. That's, from what I understand, it's all being lumped under artifacts now, but that's not a. We have it over here, but it's not in the pipeline. All the docs show it in the pipeline, which is kind of different. So I think maybe the version that Google's running of Kubeflow on its AI platform. See, oh, yep, yep, that's why. Or 1.04, and Google, and that's on 1.1. So what different? But yeah, so you can create those visualizations. I'm still trying to kind of wrap my head around how to get that formatted correctly and get those to show. So that's definitely kind of some ground that we could gain. Go back to the job here. So it's spinning that job, right? Yeah. So any kind of visualizations there, you can create functions to create those visualizations. So you can see them. ML metadata, right? So this is because I'm submitting to Cloud Job. There's going to be some inputs and outputs here that could come. If there are any persistent volume mounts, they would show up here. So you can see what the container inputs were supplied as for each one of these. See what they were and what they put out. And any kind of artifacts that were created and where they're written to. So same thing here. Yeah. So we'll give it a second here.
So far we're just waiting for Kubeflow to spin up. We're not actually doing the training yet.
Yeah, so Kubeflow is actually spun up. It's AI platform. We're just waiting on C3.
Okay.
Yeah, we're just waiting for it to do it. It just takes a minute.
So from a cost perspective, what cost elements are going on here? Where do they land? Do you know?
That's a good question. Yeah, so we've got the cluster cost. So we got that, the runtime on that. So whatever whatever's being charged for whatever type of size of cluster we've got. We've got the AI platform ML units cost that's being charged, right? So however fast or long our job is, we're getting charged there. Any kind of storage costs for the artifacts we're creating, which is probably gonna be minimal because it's probably not very large. GCR costs, right? Container registry costs for the images themselves. So quite a few things going into this. Anything else, Daniel? Can you think of anything else?
I think that covers it. So having a running cluster, that's something you can spin the cluster up and then kill it once you're done. But then, of course, if you do that, you've got to recreate your pipelines. And if you've got small pipelines, that doesn't take too much time. It can run really quickly. But if you want to have an environment, then you've got those container costs that are going to persist over time.
Yeah, and like for example, the first time I ran run 10 here this morning, right? It had to create, had to load the image in to the cluster at this point. So it's already done now, so it'd be fast subsequently. But the first time it ran, it was, it'd take a while to.
So for that data describe step there, are you able to actually log into that server, or is it just for demonstration purposes? I mean, how does that?
Yeah. So yeah, that's a good question. I'm assuming you could, I mean, just like Kubernetes, you can get on to any, well, I don't know if this pipeline's not, yeah, you could be able to get onto that instance. You should be able to get onto that pod, into that, right? But where I put everything out to is, let's see, not here. So I made sure that I could, visualize what was going on here, right? So like, you can just look at some of the decomposition plots here for this thing. Right. So here's the 4 bearings, and look, there's actually an issue right now with stats models, TSA. So I actually had to do this in stats models instead of data describe because you have to provide the period. But yeah, so the idea here was to create this thing and then be able to output a bunch of artifacts that you could go look at and get an idea of what the data looked like and things. So if we wanted to see the partial autocorrelation function plot here for this bearing, for bearing 1 here, this was from data describe, right? So, and then if we wanted to also get the maybe the statistics from the stationary tests for each one of these, they're here in CSV file. So that was the idea. So does that kind of answer the question, Brian? A little bit about how I'm using that, or?
Yeah, it sounds like you're actually just you're running actual code versus having a persistent notebook server up sitting in that pod. Right?
Correct. Yeah. This would just be kind of the side thing you ran, just kind of you'll see, and then maybe when you go through the run after the experiment's done, you're like, you know what? Based on what I'm seeing here, let's try these new parameters and run this thing and train it based on that. So,
got it.
That's the idea.
And I think you can access the containers when they're running, but they are ephemeral as far as I understand. So like those containers are just going to run, and then once they're done, they're going to be destroyed after that.
Well, kind of like anything else that's containerized. I mean, you could set it up to be persistent, right? That it just runs forever.
Yeah, you could.
Yeah.
Okay. Yeah, so that's the one thing. I mean, obviously this is Kubeflow Pipelines, right? Kubeflow itself is its own ecosystem, and I think there's obviously there's Kubeflow serving, for serving up your models, and then there's obviously just Kubeflow, which you have your notebooks and things like that, which is more of a persistent notebook on the server, on the cluster, which then allows you to create pipelines and things.
So if you're gonna, so this is all Kubeflow Pipelines, right?
Yeah.
If you were gonna use Kubeflow serving, would that be duplicate in what you have with your model serving, API serving in AI platform, or would you still do that?
That's a good question. Maybe I think maybe some of the team could even answer that better. But yeah, there's a little bit of duplication there. I mean, I think Kubeflow serving might open up some more doors. What you're allowed to serve. Maybe AI platforms I think is a little bit more picky, right, about what you're able to actually bring up to it. And I think David, you guys know the answer to that. So I think that, I think with Kubeflow Server, you can provide a custom image again, a custom container. So you might be able to use some really abstract or maybe kind of exotic libraries that may not be available in AI platform. That might be the one advantage.
Yeah, I have a question on the, have you found any way to be able to do the hyperparameter tuning natively on the Kubeflow cluster rather than using AI platform?
Yeah, so I mean, I guess the way you would do the hyperparameter tuning is you would just need to build that into your container image, and then just like I did for data describe, you would just create your own custom image for that, right? And run your code kind of as a standalone code, do your hyperparameter tuning within that image, and save out your artifacts. You just have to be more explicit as to where things are headed, and but which is what I kind of did here anyway. But is that kind of where you're going with that, or?
No, because I thought there was I think they called it Katib.
Yeah.
Yes.
There's like a specific service tool that I was under the impression that it will spin up multiple pods when you're doing hyperparameter tuning, so you can actually do it in parallel, rather than if you do your hyperparameter tuning in a single training container, then you're only using one pod, right? So it's not actually spinning up more instances. So I was wondering if there was an easy way to do that, because I haven't been able to figure it out.
Mm-hmm.
Yeah, I'm with you, David. I've looked into that library just a little bit, Katib, and it is for hyperparameter tuning. But yeah, I haven't done much with it yet. So that's a good one to put on the list.
Yeah, and from what I looked at that as well, and from what I could see is like Katib or whatever is kind of part of the more standard Kubeflow deployment. Whereas if you're deploying these clusters from AI platform, you just get kind of the bare metal Kubeflow pipelines deployment. You don't get the full suite of tools. So maybe you'd have to install those as an additional library potentially on that cluster, if I'm not mistaken.
That's a really good call out, actually, that Ryan mentioned. So a lot of the documentation on Kubeflow and Kubeflow pipelines is different from what you'll see in AI platform and the app that gets deployed on Google Kubernetes from the marketplace. So one big difference is that the one on GCP doesn't have notebooks. The notebooks that are used are just assumed that you're using AI platform notebooks to interact with Kubeflow. So that's missing from the GCP Kubeflow deployment.
I think future work is we're kind of wrapping up on time here, David. I think the answer to, I think definitely those are two things I want to understand better is the Katib, the hyperparameter tuning part of things, native to Kubeflow, and then also the Kubeflow serving. It's kind of the next, I think, steps to understand what are the advantages and disadvantages versus what's already available on AI platform.
Well, and one thing I'll mention too. So there's TFX, so TensorFlow Extended, which is kind of its own like pipeline orchestration engine, and I haven't looked into that a ton yet either. But what I have looked at and seen is that you can, so with TFX you can choose your orchestrator. So you can choose to use I think it's Dataflow as a backend, and you can choose to use Kubeflow as a backend. And it looks like all you need to do is just supply it that endpoint that we talked about in the presentation. So you've got a cluster, you just get the endpoint to that cluster and you supply it to TFX, and it will run its jobs on that cluster. So I think that's something we can look forward to as well.
Yeah, I've done a little bit with TFX in the past, and it's just kind of a suite of tools that anytime you're doing TensorFlow, it just kind of gives you some bare bone or some basic building blocks to create kind of a standard pipeline, and then like Daniel was saying, just easily deploy that then to Kubeflow as its own components or any kind of thing. I think Airflow too. You can run on Airflow too. I think there's DAG runners Airflows too as well. So cool. That's all I've got. So yeah, it looks like our pipeline did complete successfully here. So